Hello again. In this video, we're going to go over section 2.6, part 5, which is about continuity on an interval. Okay, so before we talk about continuity on an interval, let's talk about continuity at endpoints. So a function f is said to be continuous from the right, or right continuous at a, if the limit of f of x as x approaches a from the positive side is equal to f evaluated at a. And f is said to be left continuous, or continuous from the left, at b, if the limit of the function as x approaches b from the negative side is the same as f evaluated at b. So let me show you in this diagram what it means to be right continuous and left continuous. So suppose you have this function here, and you can see you have endpoints of a and b. Let's see if it's right continuous at a. So in order for it to be right continuous at a, the idea is we're going to look at the limit of this function as x approaches a from the positive side of a. Okay, so you can see as x approaches a from the positive side, you're getting closer to this y value here. Now, is that the same as f evaluated at a? And the answer is yes. If you evaluate f at a, the y value that you get is the same y value. So the limit that this function is approaching as x approaches a from the positive side, that limit, that y value, is the same as f evaluated at a. And so for that reason, right, because these are equal, it's said to be right continuous at a. Now, is it left continuous at b? Well, to be left continuous at b, the limit of this function as x approaches b from the negative side of b would have to be the same as f evaluated at b. So let's look. The y value that you're approaching as x is getting closer to b from the negative side appears to be this y value here, and that's the same as f evaluated at b. So yes, it's left continuous. All right, so this function is both right continuous and left continuous. Now, let's say your function looked like this and you had a little hole here right at b. Well, then it would no longer be left continuous. It would still be right continuous, but it's not left continuous because the limit that you're approaching here would be this y value here, but f of b is undefined. So it can't be left continuous at b. Okay, if it looked like this, then it would no longer be right continuous. Again, as you approach a from the positive side of a, you're approaching this y value, which is not the same as f evaluated at a. Okay, so it's not right continuous there. And of course, if it looked like this, it would not be right continuous, nor would it be left continuous. Okay, so that's what we mean by continuity at endpoints. Okay, let's talk about continuity on an interval. So a function f is continuous on an interval I if it's continuous at all points of I. And if I contains its endpoints, continuity on I means continuous from the right or left at the endpoints. Okay, so let me illustrate this idea of continuity on an interval by looking at example 6. All right, so we're going to determine the intervals of continuity for this function, which, by the way, is a piecewise function. Notice the output of this function is x squared plus 1 as long as x is less than or equal to 0, but it's actually 3x plus 5 if x is greater than 0. And I think the easiest way to approach this is to graph this function. And so the graph of this function would look like this. Now the reason is, as long as x is less than or equal to 0, the output of this function is this parabola, right? And that parabola, x squared plus 1, looks like this. I mean, x squared looks like this. When you add 1 to it, it shifts it up 1. All right, so x squared plus 1 would be this parabola. But the output for this function is x squared plus 1 only for values of x that are less than or equal to 0. So this part gets cut off. It's only this part of the parabola, including this point here, because when it's equal to 0, it's still the parabola. The output is still the parabola. Okay, now on the other side, when x is greater than 0, it's actually this straight line, right, with a slope of 3 and a y-intercept of 5. So here's the y-intercept at 5, but it actually never reaches the y-axis because it has to be greater than 0 to be the line, right? Once it's equal to 0, it's actually, the output is the parabola. So when x is 0, you actually get this point out here. Okay, but it would have a y-intercept of 5 if it continued on and hit the y-axis. So we're going to put an open circle there at 5, and then draw the line this way, so this has a slope of 3. Okay, which is exactly what this line would be, right? A slope of 3 and a y-intercept of 5. Again, though, it never reaches the y-axis, and so at 5, there's actually a little hole there. Okay, so that's the graph of this piecewise function. Now, let's see where this, what intervals this function is continuous on. So I think you can see, starting at negative infinity, you can draw this graph without lifting up your pencil all the way up until you get to this point up here. So it appears to be continuous from negative infinity all the way up until 0. And now the only question is, do we include 0? Well, we would include 0 if it's left continuous at 0. So the limit as x approaches 0 appears to be 1. Is that the same as the function evaluated at 0? And the answer is yes. F evaluated at 0 is also 1, right? The limit as you approach 0 from the negative side is 1, and f of 0 is 1, and so it's left continuous at x equals 0. So yes, you would include the 0. So it's certainly continuous on this interval, right? From negative infinity up to 0, including 0. Okay, now let's look at this side. I think you can see that it's continuous as you head towards infinity. But then as you get closer and closer to the y-axis, at some point you have to lift up your pencil, right? And it looks like at x equals 0, you'd have to lift up your pencil. Now, the only question is, would you include 0? Well, we'd have to check and see if it's right continuous. Okay, well, the limit as you approach 0 from the positive side appears to be 5, but f of 0 is not 5. F of 0 is 1. Okay, and so for that reason, it is not left continuous. And so you would not include 0. Okay, so the interval continuity over here would be 0 to infinity, not including 0. Okay, and so the answer is f is continuous on this interval and on this interval. Okay, so that would be the intervals where the function's continuous. Okay, so that's a kind of a good application of what we mean by continuity on an interval. Okay, I hope you found this video helpful. Thank you for watching. Bye-bye.